Another way to simulate transport is to trace particles through the flow. There's a physics interface for doing this that you can add to your model by going to the fluid flow physics, and right there, if you enter that, if you include that physics interface, then you can do particle tracing. I've already done it, and so let me show you how to set that up. Here's particle tracing, and what I'm doing is going to put in some particles, trace them through the flow. The particles will have some properties. The default properties is that the particles are what's called Newtonian, which means that the particles will have some mass, and that will affect the flow. So let's see, particle properties are here, their mass is given here, the density is 220, so this is like a mineral density, and the particle diameter is 1 micron. So this would be a small clay particle, for example, that's going to be suspended in the flow. Now, in order to have it move with the flow, we need to give it a drag force. So that's done here with the drag force. Added that, and I gave it this velocity field, and that's all that I needed to do for this setup. The viscosity is from the fluid, and I'm not going to use any turbulent kinetic energy. And so the particles are allowed to come into the model here. Let's see if we blow that up. Right there, that's selected. And one thing I should point out, that when I set this up, for some reason I had difficulty actually clicking on that edge and selecting it. So I went over here to the selection list, and I was able to pick the number here, pick the number 12, and then press the plus button to add it. So I'm not quite sure why that happens, but it does sometimes. And so if you can't select it with a mouse, then you could select it off of the selection list. So the particles are going in there. I give it the initial velocity, and there are a number of ways that you can add particles. I'm putting a uniform distribution of 20 particles along that boundary. And then you have to have a way for the particles to get out, so I have an outlet there, and that's it for just the preliminary setup. And then we can run it, and actually let me show you this. When we set this up to run, we have a new study, and I'm only going to run the particle traces for the fluid flow, because what I'm going to assume is that the physics, or the velocities, are not changing. And so I solved for the velocities before. They're not changing as a result of interactions with the particles. So I can simply go values of variables not solved for and select the last time. Now, if I wanted to use transient velocities, then I would go, and instead of selecting last, I would select all. That way, if I have a storm pulse coming into this system, I would select all, so that the velocities could change with time. That takes a bit longer to run, so I'm just going to assume that that the velocities don't change through the analysis. So if we go and run this, we can see there'll be some particles that they're the particles. I have particles, and I also have lines that are following the particles, and so there are quite a few particles together, so we don't really actually see the individual particles in this plot. Now we can start to see them separate a little bit as they disperse in the flow. This is using the shallow water equations, and so you can see the particles moving down. These are the particles right here that were released at the beginning of the model. For the plots, we can go and adjust a variety of things. These lines here are tubes, and tubes are features that you can adjust the width of, so we can make them skinnier. They're very thin and barely show up. We could make them lines, in which case we can adjust the thickness, or we could just simply turn them off. And now we just have the points. We can adjust the size of the points. So if I make them a little bit smaller, there they are. They have this scale factor that you need to fix if you want to adjust the size of them. And let's see, we can also adjust the color. You can see these are different colors, and the default is that the colors are the velocities of the points right here, but we could change that if we like. Okay, so another thing that we might want to do is put the particles in different places initially, and so I've used release from grid here that I selected right there, and I went in and put in some points over a grid, and the points will be now released right around in this vicinity. And so when I run it now, here's what happens. So I've changed the output format a little bit. You can see the particles are now much smaller and they don't have those tails on them. But I think hopefully you can still see these particles. And there's the particles that are that were released initially. They're coming out, and then you can see the particles right in here starting to move around. They're changing colors with the velocity, and you can start to see these particles moving a little bit. I think this probably would be a little bit better if we had the tails on them, or if we had the lines, although this is showing pretty well, I think, the trajectory of these particles. Okay, so I think you get the idea. Go ahead and use this feature to evaluate how the flow is going. Now, I should point out that you'll get pretty much the same results here as you will with streamlines if the velocities don't change. Well, that's not true. If the velocities don't change and if there's no mass. One of the nice things about this feature is that you can change the properties of these particles. So you can compute the mass, you can have the mass change, you can have the change temperature. Because it has mass, you can give it a body force and you can have it settle. So you could do sediment that's being transported. Really a variety of things that would go much beyond, say, the streamline capabilities that you have in post-processing. The other thing that is pretty powerful is that you can trace the particles through a transient flow field. So if we were interested in the effects of a storm pulse, you might imagine that the flow coming in here would be slow at first, and then it rises up and is quite fast and then falls. And so the flow is transient, and the particles would the directions and the locations of the particles would respond to that transient velocity, and so we can trace them through this transient velocity field by simply going and selecting all of the results here from the velocity simulation.